In this video, we're going to discuss the distributive law. This is a very important rule because anytime you have an expression that has more than one operation, the distributive law will tell you what to do. So, the distributive law, in an informal definition, tells you how to deal with more than one operation in an expression. So formally, if we look at the definition below, we say that star distributes over circle plus if the equation below is true for every single choice of A, B, and C in whatever set we are working in. So this is probably best described as the action of A star distributing over the B and the C surrounded by the circle plus. So the A star gets distributed to the B and gets distributed to the C. So it's distributing over the operation of circle plus. And the result is the A star B circle plus A star C. Now, one thing to consider closely here is the order is important. In this definition, we're saying that star distributes over circle plus. But we could switch the order around and put the circle plus here and the star here, and we would just have to switch the circle plus and the star in the equation below. Now let's discuss an example. So in the tables below, we have the operations meets and hugs. And we want to know if meets distributes over hugs. So we have an equation to check. Let's write this equation down. So copying the equation from above, it's A star distributing over B circle plus C. So the A star is distributing to the B and is distributing to the C. So the other side of the equation would be A star B circle plus A star C. But in our situation, we don't have star and circle plus. These are just arbitrary operations that we use to describe what the distributive law is. Here we have meets, and it's distributing over hugs. So we need to replace the star with meets and the circle plus with hugs. So this is what we actually want to test for this example. Now, we need to decide if this equation is true or false. Let's look to hugs first. Hugs is kind of an interesting table because every single result in that table gives you happy. So no matter what, the hugs on the right-hand side will come out as happy. And the hugs on the left-hand side will also come out as happy. But that result will also be met with any A from our set. So happy, unhappy, or surprised. And that result is not necessarily happy. So we can plug in whatever we like for A. Let's say we plug in unhappy. And on the left-hand side, we get surprised, but that's not the same as happy. So the equation is not true in this example. In order to be distributive, it would have to work for every A, every B, and every C in our set, and we found one example where it doesn't work, so the answer to this question is no. Okay, we're going to try the same example, but we're going to spin it around. This time, we're going to ask, does hugs distribute over meets? So the equation that we want to test out this time is, so again, to decide if this equation is true, we'll use the fact that every single result in the hugs table is happy. So H for happy, we'd have H there, and H there. No matter what the A and B and C is, you get happy as a result of hugging. So on the left-hand side, we get happy no matter what. On the right-hand side, we have happy meets happy, and that result is happy. Happy meets happy is happy if we check on the table above. So in this case, regardless of the A and B and the C, we get happy on both sides of the equation. So we can say, yes, hugs distributes over meets. So now let's discuss whether some of the basic operations are distributive over the real numbers. So first, does multiplication distribute over addition? So what we're asking, if we take A multiplied by B plus C, is that the same as distributing the A to the B and the A to the C? So we would get AB plus AC. Notice we don't write the multiplication symbol, but the A multiplied is being distributed to the B, so you get A multiplied by B, and the A multiplied is being distributed to the C, so you'd get A multiplied by C. So it turns out that this is true. We can take this for fact that multiplication is distributive over addition. Let's try for subtraction. So a similar expression would come up. This time it would just be A multiplied by B minus C. So we would like to know if we can distribute the A into the B and the C. Now it turns out that this is true as well, but we can actually do a proof. We can write down a reason why this is true. And the first thing that I'm going to do is change the subtraction symbol to addition. So this would become A multiplied by B plus negative C. This is another viewpoint on subtraction. Instead of subtracting positive C, we can add a negative C. So looking above, we now know if it's a fact that multiplication distributes over addition, that the A multiplied can distribute to the B, and the A multiplied can distribute to the minus C. So as a result, we would get AB plus A minus C. Now finally, we can change that negative symbol back to subtraction, and we have the result that we would be looking for. We would have AB minus AC. And notice in the end, the A has been distributed to the B and the C. So there's also a special case to watch out for when you have a non-commutative operation. So if the order is important with the star operation, there's two different ways to interpret the distributive property. So let's look right here where we have A star. A star distributing from the left would go to B and C from the left-hand side and give us what we'd have on the right-hand side, just like earlier on in this video. But if the star is not commutative, if the order matters for star, then it would mean something different to distribute from the right. So we've looked at scenarios where the star was multiplication earlier on, so the order didn't matter. We didn't have to worry about this left and right business. But here's an example below where we ask, does subtraction distribute over multiplication? And we clarify from the left, because it's different to say distributing from the right or the left, because subtraction, this operation itself, is not commutative. So let's set up this equation correctly. So we're asking from the left, so it would be a minus b multiplied by c in brackets. And we're asking, does the a minus distribute to the b and the c? So the result of this equation that we'd be looking at is a minus b multiplied by a minus c. So let's try an example. Let's just plug in some numbers. Let's say a will be 0 and b and c will both be 1. So we'll plug in 0, we'll plug in 1s, we get 0 minus 1 and 0 minus 1. On the left-hand side, we have 0 minus 1, so that's negative 1. On the right-hand side, we have negative 1 times negative 1, so that's positive 1. And we can see that these two expressions are not the same. 1 is not the same as negative 1, so we have a counterexample that shows that subtraction is not distributive over multiplication.